Hi everybody, I am going to do a little review of exponents that we covered with regard to applying the power rule to take derivatives. So this is really important. A lot of times when we encounter functions, they have exponents. They could be in the denominator. And before we take the derivative, it's helpful if we can write these functions as power functions. And similarly, if we have radicals like this, if I can write it with a fractional exponent, that will allow us to use the power rule to take the derivative. All right, so let's take a look here. Just a quick overview. If I have any variable x and I'm raised to a power, in this case negative p, I can rewrite that with a positive exponent by, you can think of this as x to the negative p over 1. I can take the reciprocal, or I can flip it. I can put that in the denominator, and notice what happens. This negative p becomes a positive p. Likewise, if I have a variable x right here raised to the negative p, if I want to get this variable out of the denominator, I can bring it up into the numerator, and what I do is that negative sign in front of the exponent becomes a positive sign. So here, for instance, I have p to the negative 7th. If I wanted to write that with a positive exponent, that becomes 1 over p to the 7th. If I have 1 over x to the negative 5th, I can write that in the numerator. I can get that variable out of the denominator and write that as x to the positive 5th. Essentially, I'm saying x to the first to the divided by 1. Same thing here. If I have, so whenever I'm like switching the position of the variable raised to an exponent, when I switch it from either position, I just take the whole variable and I make the exponent negative. Here, I've got n to the 4th in the denominator, and if I bring it up into the numerator, all I do is I make that 4th power negative. All right, so we're going to be using that rule a lot. We're actually going to go, whenever we see a variable in the denominator raised to a power, we want to write it so that it's not in the denominator, so we can take the power rule. All right, another rule we're going to use a lot is rule of exponents. So when we have a radical, so this is a radical here, that's square root, or we can say the nth root, I can rewrite that as a power function. Remember, a power function is a variable raised to a number power. So I can write anything that's in radical form as a power function with a fractional exponent. So this first one is, whenever I don't see anything in that root index, it's a square root. And whenever I don't see a power underneath, it's to the first power. So I could write this as x to the 1/2. Here, this is x to the 1/3. So whatever the power is underneath the radical here, that goes in the numerator. And whatever this root index here is, it goes into the denominator. So let's take a look at this last example here. So this is, my variable is x. The numerator of the fractional exponent is going to be 2. The denominator is going to be that root index. I can write that as x to the 2/5. And here, again, when I don't see anything in the root index, it's the square root. So this becomes x to the 7/2. All right, so notice then, each of these now is a power function. It's a variable raised to a power, a variable raised to a power, a variable raised to a power, a variable raised to a power. And then if I want to take the derivative, I can apply the power rule. So let's look at some examples here. We're going to kind of mix the two things. So whenever you look at a function like this function a of x, I'm going to scan through. What I want to look for is radicals. All right, and if I see a radical, I want to rewrite it with a fractional exponent. And then if I see any variable in the denominator, I want to rewrite those as a power function. So I'm going to bring that variable up into the numerator. So the first thing I like to do is I like to take them one step at a time. So I'm just rewriting this function. I'm not taking the derivative. So a of x is equal to 7 over x. Now I'm going to rewrite this term with a fractional exponent. That's the square root of x. So plus x to the 1/2. Now I'm going to rewrite this term plus, here's my constant, 120 times, this is x to the 1/3. All right. So now the next part, so I rewrote my radicals with fractional exponents. Now I want to deal with this term here. So this is x to the first. So I'm just going to, again, I haven't taken the derivative at all. I'm just rewriting this function. And because I want to bring this up into the numerator, that's going to become 7x to the negative first. I just make that exponent a negative, plus x to the 1/2 power plus 120 x to the 1/3. Now I'm ready to take the power rule. I have a power, every term is a power function. I have a constant times a variable raised to a power. Variable raised to a power, a constant times a variable raised to a power. And so I can apply the power rule. So only now am I going to say, I'm going to take the derivative a prime of x. And the way I do that is I take my exponent and I bring it down. So that's -1 times 7 x. And now I'm going to subtract 1 from the exponent. -1 minus 1 is -2. Plus, I'm going to take my exponent, I'm going to bring it down, 1/2 x. I subtract 1 from 1/2, that gives me -1/2. Plus, I'm going to take that exponent, I'm going to bring it down, 1/3 times 120 x, and then I'm going to subtract 1 from 1/3. That's 1/3 minus 3/3, right? I need to have a common denominator, so this becomes -2/3. So now what I would do lastly is I would clean this up. All right, so a prime of x is equal to -1 times 7 is just -7 x to the -2 plus 1/2 x to the -1/2. And then 120 divided by 3 is 40. So 40x to the -2/3. That's my answer. Let's look at another one. So I want you to scan first and ask yourself, do you have radicals? I want you to do those first. Yep, so here's a radical, and I want to take care of those first. So my first step is I'm going to rewrite this. So this, I'm not taking the derivative, I'm just rewriting this. H of p is equal to 12 over p plus 2 over p to the 7th plus 6 over, notice I don't have any exponents, so this I can just write as p to the 1/2. So I rewrote my radicals. Now I'm scanning, do I have, I can see I do I have any variables in denominator? Yep, here, here, here. So I want to rewrite those so that I don't have the variable in the denominator. So what I'm going to do is h of p is equal to, this is p to the first. If I bring it up into the numerator, I make that exponent negative. So this is 12 times p to the -1st plus, if I want to bring this up, I make that 7 exponent negative, 2 times p to the -7th. And then I can do the same thing. It doesn't matter that I have a fractional exponent. When I bring it up from the denominator, I just make the exponent negative. So this is 6p to the -1/2. So I didn't take the derivative. All I did was just rewrite h of p here. Now I'm going to take the derivative. So then, okay, I wrote this as a power function, each term as a power function. This is a power function, this is a power function, this is a power function. So now I'm ready to apply the power rule to take the derivative. And that's going to give me h prime of p. And I take my exponent and I bring it down here, -1 times 12 p, and I subtract 1. -1 minus 1 is -2, raised to the -2nd. I'm going to do my next term now. I'm going to take my exponent. I'm going to bring it down. I like to do it in pieces. Negative 7 times 2. All right, now I'm going to subtract 1 from this. Negative 7 minus 1 is negative 8. And then my last term here, I'm going to take my exponent and bring it down. That's negative 1/2 times 6 to the p. And to do this, I'm going to subtract 1. Negative 1/2 minus 2 over 2 is negative 3/2. Negative 3/2. All right, my last step is, in some cases you can just leave this, but in this case I would actually simplify it. Let's rewrite this thing in simplified form. H prime of p is equal to, I take negative 1 times 12, so that's negative 12 p to the negative second. All right, negative 7 times 2 is negative 14 p to the negative 8. And then negative 1/2 times 3 is minus 3 p to the negative 3/2. So again, first you're going to see, do I have radicals? If you do, you're going to rewrite the radical with a fractional exponent. Then you're going to scan to say, do I have variables in the denominator? And if you do, then you're going to rewrite the whole function as a power function. So bring those variables up into the numerator position using exponent rules, and only then are you ready to take the derivative.